Assalamualaikum and hi. Today we are going to talk about electromagnetic compatibility, or we can call it as EMC in electronics. So let's get started. In this video we have a few contents such as group members, introduction of EMC and significance, relevant electricity and magnetism concept, exploration of EMC application or technology, example of real-world implementation, benefits and challenges, future development, and lastly conclusion. For this video, we have three group members. Firstly, Nur Syafiqa Alia binti Zulkarnain. Secondly, Nur Hamiza binti Abu Bakar. And lastly, Alice Azlin binti Ruzaidi.
I am going to present to you guys about introduction of electromagnetic compatibility. Electromagnetic compatibility is the ability of electrical equipment and systems to function acceptably in their electromagnetic environment by timing the unintentional generation, propagation, and reception of electromagnetic energy, which may cause unwanted effects such as electromagnetic interference or EMI, or even physical damage to operational equipment. Significance of electromagnetic compatibility. The first one is preventing interference. Electronic devices emit electromagnetic radiation, which can interfere with other devices operating nearby. But electromagnetic compatibility ensures that devices do not interfere with each other, preventing malfunctions, data corruption, or safety hazards. The next one is ensuring functionality. External electromagnetic fields can disrupt the operation of electronic circuits. So, electromagnetic compatibility standards help devices withstand this external disturbance, ensuring their intended functionality. The third one is enhancing system reliability. Electromagnetic interference can lead to unpredictable device behavior, system crashes, or data loss. So, electromagnetic compatibility compliance helps minimize this risk, improving system reliability and reducing downtime. The last one is safety and security. Uncontrolled electromagnetic emissions can pose safety hazards to humans and animals. Electromagnetic compatibility regulations and standards ensure that devices operate within safe limits, protecting users and the environment. The next one is electricity concepts. What is the relationship between electromagnetic compatibility and electrical currents? Electromagnetic compatibility focuses on managing electromagnetic interference, and electrical currents are a primary source of this interference. The key electrical concepts in electromagnetic compatibility is current, voltage, impedance, and frequency.
Next, we have electricity concepts on electromagnetic compatibility. The first point is electric current. Electric current is the movement of electric charge through a material. It is measured in amperes. Electric current have direct current and alternating current. In direct current circuits, electric charge flows in single directions. This is the type of current used in batteries and many electronic devices. And alternating current. In alternating current circuits, electric charge periodically change directions, reversing their flow at specific frequency. This is the type of current used in most household outlets. Next, we have voltage. Voltage is the electric potential difference between 2 points in a circuit. It is the force that pushes electric charge voltage means a stronger force pushing the charge, leading to a larger current flow. And lower voltage means a weaker force, resulting in a smaller current flow. Voltage is measured in volts. Next, we have impedance and frequency. What is impedance? Impedance is a measure of a circuit's opposition to alternating current measured in ohms. Frequency is the rate at which an alternating current changes direction measured in hertz. Frequency is the rhythm of alternating current. It tells us how often the current direction changes per second. If we have higher frequency, this means current changes direction more rapidly, like fast flowing water. And if we have lower frequency, this means the current changes direction more slowly, like slow moving water.
Next, we have magnetic concepts. EMC is concerned with managing EMI, which can be caused by magnetic fields. These fields can disrupt the operation of sensitive electronic devices. The first point is magnetic field. These fields are invisible lines of force that surround by magnets or moving electric charge. Next, we have magnetic flux. Magnetic flux is a measure of the total magnetic field passing through a given area. And we have magnetic permeability. This is a material's ability to support the formation of magnetic fields. And lastly, we have magnetic induction. This is the process of creating a magnetic field by changing the electric current flowing through a conductor. So, how electricity and magnetism play a role in EMC? Electromagnetic waves are formed when electric and magnetic fields oscillate together. These waves travel through space at the speed of light, carrying energy. The spectrum of waves. Electromagnetic waves come in a wide range of frequencies, from low frequency radio waves to high frequency gamma rays. And the source of EMI is these waves are the primary means by which electromagnetic interference travels and affects electronic devices. Next, we have interference mechanism. The first point is conducted EMI. Conducted EMI occurs when electrical noise travels along physical connections like wires and cables. This can happen due to voltage spike, current surge or ground loops. And second one is radiated electromagnetic interference. Radiated EMI happens when a device acts like an antenna, radiating electromagnetic waves that can interfere with other devices in the vicinity. Lastly, we have importance of EMC design. EMC design focuses on controlling both electric and magnetic fields to minimize interference using techniques like shielding, filtering, and grounding. Shielding is enclosing a device or circuit in a conductive material that blocks electromagnetic waves, preventing them from radiating outwards or entering the device. Filtering, using electronic components like capacitors and inductors to block specific frequencies of interference that can help prevent noise from entering or leaving a device. And lastly, grounding. Creating a common reference point for all electrical components in a system that help minimize ground loops and reduce the flow of interference through unintended paths.
Moreover, I would like to present about exploration of electromagnetic compatibility (EMC) in application and technology. Therefore, in application, it will ensure the correct operation in the same electromagnetic environment and address the countermeasure. Other than that, a lot of EMC was used in technology, for example, medical device, such as MRI machine, X-ray machine, pacemaker, and so on. EMC also used in wireless communication such as 5G network, Wi-Fi, and so on. Furthermore, I would like to present to you about example of real-world implementation. Firstly, mobile phones are designed to minimize electromagnetic interference (EMI) through various methods aimed at reducing emission and ensuring compliance with regulatory standards. Designing for reduced emission involves incorporating shielding materials like copper or aluminum around sensitive components, as well as careful antenna design to limit unwanted radiation. Other than that, filters are used in power supply and communication circuits to reduce conducted emission that could affect other devices or degrade performance. Next, conducted emission control ensure that EMI generated within the phone, such as from power management circuits, is minimized through the use of components that suppress high-frequency noise. Finally, ensuring compliance with standards like FCC helps guarantee that the phone both presents emission that could disrupt other devices and is immune to external interference, resulting in a safer and more reliable user experience. Secondly, in automotive electronics, conductive shielding is essential for protecting sensitive components like ECU and infotainment system from external EMI. Other than that, surge and overvoltage protection safeguard systems such as electric drivetrain and battery management from voltage spike and surge using devices like surge protectors and transient voltage suppressors. Furthermore, radiated emission control ensure that wireless systems such as Bluetooth or GPS do not interfere with other vehicle components or external devices. Lastly, techniques like antenna design and shielding reduce emission, ensuring compliance with standards like ISO 11452 and ensuring safe, reliable operation of automotive electronics. Thirdly, medical devices in MRI machines. In MRI machines, shielding and grounding are essential to prevent electromagnetic interference (EMI) from affecting both the device and nearby equipment. Shielding contains the machine's strong magnetic fields and signal, while grounding safely directs unwanted currents away. Furthermore, to ensure immunity to external EMI, advanced shielding, proper component placement, and filters are used, allowing the MRI to function reliably in environments with other electronics. These devices undergo rigorous testing and certification, such as IEC, to meet safety and performance standards for both immunity and emission, ensuring their safe operation in medical setting. Last but not least is industrial automation system. Shielding, filtering, and grounding are crucial to protect sensitive components from EMI. Shielding prevents interference, filtering reduces conductor EMI through power lines, while grounding safely diverts unwanted current. EMI suppression in motor ensures smooth operation by using filter and shielded cables. Compliance with standards like IEC 6100064 and IEC 6100062 ensure system meet emission and immunity requirements. Designing for immunity ensures this system remain reliable and safe, even in high EMI industrial environment.
There are a few benefits of EMC. First, reduce interference. Do not emit excessive electromagnetic radiation that could interfere with nearby equipment. Interference means combination of two or more waves that moving on intersecting or coincident waves. Second, energy efficiency. By minimizing our electromagnetic emission, our devices can operate more efficiently. Third, better signal integrity. It is to prevent noises and interference that could degrade data quality. Next, there are a few challenges of EMC. First, stricter standard. The new technology such as 5G introduce new interference that needs ongoing update to EMC strategies. Second, a balanced functionality with emission control. Ensure that it is compact, feature-rich devices and do not generate harmful interference. For example, the design of consumer electronics such as smartphone demands a balance. Or lastly, miniaturization of components. Maintain the EMC performance since there is less space for protection solutions. Other than that, we have future development. First, EMC in electric vehicles. To ensure that the circuits generate EMI do not radiate or conduct the interference. The second, the new standard of EMC. The new standard are created to reduce EMI and we focus on hazard detection. Lastly, materials innovation. Sophisticated and higher quality of material could provide more quality of product.
In conclusion, electromagnetic compatibility (EMC) is critical for ensuring that electronic devices operate reliably without causing interference or being disrupted by external electromagnetic noise. Implementing effective EMT strategies not only ensure regulatory compliance but also protect users. Compliance with global EMC standards is essential for manufacturers to meet safety and performance criteria in diverse markets. Therefore, it will help to ensure that products can be sold globally and that they do not contribute to harmful electromagnetic. Other than that, electromagnetic compatibility is not just a technical requirement but a foundational element of modern electronics that supports safety, reliability, and innovation across industry. The need for continuous innovation in EMC design and testing will be essential to support the future of connected and advanced electronic systems.
Thank you for watching our video.